Good morning, everyone. My name's Rob Moore.
My name's Matt Davies, and we're principal consultants at Redify. So we're here today to talk to you about contemporary authentication. So authentication's obviously a pretty hot topic in the last couple of years. There's password breaches every week. There's people getting hacked left, right, and center. There's a lot of examples of people doing things in ways that could definitely be improved. So that's something that we really want to talk to you a bit about today. But what we found when we started researching some of this stuff is that it's really, really difficult to understand exactly what's going on. Every time you do any searching for how anything works, you come up with pretty complicated spec documents. You come up with all sorts of stuff, all sorts of crazy definitions, all sorts of stuff that's really, really difficult to follow. So one of the things that we wanted to do, especially on a morning right after a crazy boat cruise, is come up with some really, really simple explanations of what's going on and try to use some consistent terminology so that it's hopefully reasonably easy to follow. So we've broken this talk up into 4 parts. We've got the why of authentication. Why do we even care about this stuff? We've got the what, so some of the different terminology that goes on, some of the different basic concepts that we really need to be aware of. We've got the how, so what are some of the different protocols and standards that are involved in some of this stuff, and then we're going to deep dive into one of those standards in particular, which is called OpenID Connect, which we really believe is one of the fundamentally important ones to be across at the moment, because it's basically everywhere.
Cool. So let's start with the why. Why are we standing here talking to you? Now, if we start by looking at a traditional application,
monolith,
pretty much everything within the application is within the bounds of a single application, right? So you've got your UI, business logic, data layer. The UI is going to take credentials from the user, pass it across to some sort of authentication source and check the credentials itself, and then it will do some sort of lookup to check authorization.
Cool. So if we look at a more modern application, we're seeing today a couple of different things. The first thing that we're seeing is that people are quite often externalizing their identity off somewhere else outside of their application, and that's really useful for a couple of reasons. The first is that it means we can really leverage third-party single sign-on providers. We can use, for example, Google, Facebook, so on. And these guys have invested a lot of time and money and effort into coming up with really, really secure implementations of this stuff. And frankly, there's some really, really clever people who come up with this stuff, and they make sure that it works really, really well, and we get all of that for free. The second thing that we get out of this is really easy single sign-on. So users just have to maintain one identity. They can go use it in a bunch of different places. They don't have to remember a bunch of different passwords. It creates a really good experience for them. So that's the first thing that we're seeing. The second thing that we're seeing is that people are building applications in quite different ways nowadays. They're coming up with applications which are much more distributed than they used to be.
Microservices.
Much more distributed than they used to be in the past. And what we tend to find is that you use a lot of different APIs, a lot of different services. You might not own these services and APIs anymore. They might be owned by third parties. And so you can no longer trust just giving them your users' passwords. You need some secure way to pass around the identity that's being used. So it creates some interesting challenges, and this is what we want to talk a little bit about today on how to solve.
Now, certainly these, in particular, 2 things that we're noticing change the dynamic of how you perform authentication compared to what we did traditionally. But there's something else that's also really important, and it's pretty much epitomized by this website. So most of you probably know about Troy Hunt. He runs this website, haveibeenpwned.com. I encourage everyone to go there and put your email address in.
Put your friend's email in.
Put your friend's email addresses in after the talk, of course, and check out whether or not you've been in a breach. But what this website makes abundantly clear very quickly is there is a lot of breached passwords out there, millions and millions of them. But more than that, this isn't something that just happens a couple of times a year. This is literally happening every other week. And all you need to do to see that is just say, follow Troy on Twitter and look at all the breaches he talks about so often. It's frankly scary being a web developer and seeing that stuff.
Absolutely, yep.
This is why this stuff is important. If your application doesn't take a password, it doesn't need to store it, and you can't breach it. And you've completely removed a whole set of risks.
Cool.
So that's why we're here talking to you about this stuff. Let's talk about what modern authentication actually is. We find that there's a number of terms and concepts that are kind of important to understand to be able to kind of get the whole picture. So we're going to dive into a few of these and hopefully try to explain them. The first one is the difference between identity, authentication, and authorization. Now, we've actually got a nice physical example of this. So say I'm going out on a Saturday night. I decide I want to go to a pub or bar or something like that and have a drink. So I walk up to the entrance, and then there's a bouncer. Let's say his name's Matt. He's actually a little bit imposing. And what I do at that point is I say hi. Oh, where's all my... That's a bit of a fail, isn't it?
It's all right, I'll do it.
Is anyone got a clicker on them?
It's cool.
All right, so I walk up and I say, hi, I'm Rob. This is not going to work unless you
Yeah, all right.
that. Do you guys have a clicker? Thanks. Anyway, so hi, I'm Rob. That's my identity. Now, I could say anything I want to him. I could say, hi, I'm Jim, or Bob, or whatever. He's not going to know that I am, in fact, Rob until I prove myself, until I authenticate myself. Now, in this instance, that means I give him my driver's license. And at that point, I've authenticated myself. He knows I am now Rob. I've proven my identity. Now, at that point, he's still not going to let me in because he needs to authorize me to make sure that I'm allowed to come in. At that point, he needs to, in this instance, check my driver's license for my date of birth.
Cool.
Oh, thank you. And check that I am, in fact, over the age of 18.
Not actually sure you are. It might be a bit of an old photo.
So once he's checked that and checked that I'm over 18, I've been authenticated, authorized, I'm allowed access to the resource that I wanted to. So maybe a beer in this case.
Cool.
Now, this situation plays itself out in pretty much every modern authentication that's doing, modern application that's doing authentication. So this is just a physical example of it. The other thing that's incredibly important to understand is something called claims-based authentication. This is the underpinning of basically every modern authentication protocol. And we find that it's like, we got really confused. We're trying to figure out what this thing is. And being developers, the first thing we turned to try to figure out what it was is, of course, we went to Stack Overflow. Now, this is pretty much the simplest definition we've been able to find on what claims-based auth is. So this guy says claims-based authentication is about defining who you trust to give you accurate information about identity and only ever using that information provided. But let's dive in a little bit deeper and try to explain it a bit better. Again, we've actually got a nice physical example for this. If you think about the government, and more specifically the licensing department in the government, seems to be some sort of interference here.
Might be me.
The licensing department issues driver's licenses, like in the example we just showed with the bouncer. This is actually a real-world example of claims-based authentication. In this instance, the driver's license is the identity token or security token. The bits of information on the driver's license, like your name, address, date of birth, they're the claims. Claims and claims-based auth is basically just properties attached to your identity. Now, in this instance, the government is the identity provider. If we go back to that Stack Overflow quote, that's the thing that you trust. You trust that the government can identify someone. So you trust information provided by the government. In this example, the licensing department is the secure token service that issues the token. Now, there's one other fundamental piece that's missing from this that makes up claims-based authentication. It's the most important part. Because if you think about the instance where I walk up to the bouncer and I give the driver's license, he needs to check it to make sure that it's valid, that it's actually been issued by the government. Otherwise, he's not going to trust it. He needs to make sure that it's not a fake ID, basically. And that's the act of token validation. Now, in the case of the physical example, there's all these cool holographic logos and that sort of thing on the driver's license that you can look at to make sure that it's real. In an electronic example, all of this plays out in all of the modern protocols that we're going to be looking at in this talk. And for instance, say token validation is usually done as a cryptographically signed hash.
So one of the things that you might have noticed if you've done a lot of research into this stuff yourself is that there's a lot of different terms out there to basically describe the same thing. You can have names that mean all sorts of things. So one of the things that we really want to do as a part of this talk is try and use fairly consistent terminology. So when we refer to a relying party, we mean the application that's actually trying to perform authentication. When we refer to a user, we mean the actual end user that's trying to authenticate. And when we refer to an identity provider, we mean the source of truth, the entity that's actually validating whether or not an identity is correct. Now, if you look into this a bit, you might see that there's all sorts of names for this stuff. Confusingly, for example, a relying party in OAuth is called a client, but in OpenID Connect, which is based on OAuth, it's called a relying party. So it's easy to get a bit tripped up. A user can kind of confusingly be called a subject.
Such a weird term.
It's a pretty weird one. Identity providers can be called all sorts of things. So this can be a bit of a useful reference, I guess, for when you're looking into this a bit.
Absolutely. Feel free to print the slide out and pin it up on your wall so that when you're looking at the OAuth spec at like 2 a.m. you're not getting too confused.
Know how much you like doing that, yeah. When you think of traditional authentication, you might first think about password authentication, obviously the most common one out there. When we say password authentication, what we mean is that the user will directly provide their password to the identity provider. To the relying party. The relying party will then pass that password onto the identity provider and verify it. Usually that's against some sort of internal database or something like that. This is a pretty common setup, and it's a pretty big problem for a couple of reasons. The first is that password is now shared across some kind of potentially network environment in a couple of different places and could be intercepted. So we've got that password in places it doesn't necessarily need to be. The second is that this doesn't really support a scenario where that relying party isn't the owner of those passwords and credentials, because you don't necessarily know how it's going to handle them or what it's going to do with it. So there's a couple of things that we can do about this to try and sort this out.
Cool, spoiler alert. So that's where tokens come in, right? So we just talked about tokens with claims-based authentication with the driver's license example. And there's actually two different types of tokens. So there's reference tokens and self-contained tokens. Reference tokens are basically just a random string of numbers and letters and whatever it is. It's just essentially a lookup. The way that works is that the user will provide their password directly to the identity provider so that the relying party never sees it. The identity provider will then issue a reference token to the user, which they will pass on to the relying party. And at that point, the relying party will exchange that with the identity provider in return for that user's identity and claims. Now, because they've talked directly to that identity provider, where there's some trust, they know that they can trust those identity and claims. Self-contained tokens are a little bit different. So again, the user passes their password or credentials directly to the identity provider, but in return, they get this self-contained token. So weird. And that token actually contains the identity and claim information inside of it. So when that token is then passed on to the relying party, then the relying party has everything that they need to do authentication and authorization for that user. Now, there's that important step of token validation that's missing here as well. So weird. It's not clicking. And that's so that the relying party can make sure that the token hasn't been tampered with. So for instance, the user hasn't gone and added a claim saying that they're an admin user or something like that. That way, the relying party can make sure that the token is as it was issued from the identity provider, which of course it trusts. And that's the most important part of claims-based auth, as we said.
Cool. So something else that we wanted to talk about a little bit at this point is multi-factor authentication. We've got a definition up there, but basically multi-factor authentication, if you haven't come across it before, is essentially trying to use more than one proof of verification that the user is who they say they are. So typically that's by combining two different things. One of those things is something that the user knows, which is usually some kind of static password. Something that the user has, so quite typically a mobile phone or some kind of device that you can't really clone or duplicate. And lastly, you can sometimes combine in biometrics, so that's your thumbprint or something like that. And multi-factor authentication is really, really important because it gives us such a guarantee that the user is who they are as compared to just a password, which is really easily leaked out and really easily reused. Where this kind of started is commonly mobile numbers, commonly phones. It sort of evolved from there into tokens, so software and hardware tokens, which are essentially just things that the user has which generate tokens or codes according to some predefined algorithm, which the server also knows about. So it can essentially verify that the user has the same token that they should. That's evolved even further from here into using machine learning to actually analyze the user's network activity and login patterns and location and things like that to verify they are who they say they are, which gives us even more certainty. So this is evolving very quickly, but it's becoming increasingly more important to start taking advantage of some of this stuff as opposed to just using passwords. And it's really easy. Software as a service providers make this super simple. if you're using, for example, Microsoft's Azure AD, you can get all this multi-factor authentication and the machine learning side just out of the box, and the user just automatically gets to opt in and take advantage of this. So it's kind of cool, and it's pretty easy, and not many excuses left to not start taking advantage of some of this stuff.
If you want to know a bit more about that machine learning stuff, it's something called risk-based multi-factor authentication. Feel free to hit up our CIO, Teeth Moddy, and he'll talk your ear off about it for like an hour. It is pretty cool, though.
Yeah. So we wanted to jump now and talk a little bit about the how, some of the standards that are involved here. We're going to talk a little bit about token standards and the actual authentication protocols that are used. But I guess it's really important to note that standards are super important here. They give you huge interoperability out of the box. If your relying party, your application, is talking to an identity provider that follows some certain standard, you can just drop a library into your application and instantly be guaranteed that it's all just going to work. And that lets you take advantage of peer review and things like that, where really, really clever people have looked at this stuff and come up with implementations that are really, really secure, and you're at less risk of making mistakes.
Let's be honest, these people are like way smarter than us.
Yeah, way smarter than us. And I guess like following on from that point, the security becomes a lot simpler in this case, because you're again taking advantage of really large standards bodies that have figured this stuff out. They're usually backed by organizations with a lot of money and resources and time who've put a lot of effort into making these things really solid. So you get a lot out of just using them. So the first thing that's worth talking about is token formats. So we're going to talk mainly about SAML and JWT tokens. There's a few different token formats out there, but we're just going to mainly focus on those two.
So let's start by looking at SAML tokens. This is the incredibly boring, frankly, definition of what a SAML token is. Essentially, it just boils down to, it's a standard that's an XML format. It has the ability to have attributes so that you can have claim information, and it's cryptographically secure. This is what a SAML token looks like.
It's pretty crazy.
It's just gross. It's ugly. It's verbose. It's exactly what you expect and always wanted from XML. But to be fair to the SAML's token format standard, it's been around for a long time. It's incredibly robust, and it has a lot of support. So like 99% of the time, you don't have to know anything about that. You just pull in a library and it kind of works. Yeah. So it's actually pretty useful. Now, to be even fairer to the SAML token standard, if you add a bit of kind of syntax highlighting, a bit of formatting, get rid of some of the crazy XML stuff in there, then it actually ends up being quite simple if you look at it. There's essentially a header which has the actual issuer that issued the token and a signature so that you can verify that it's intact. It's got a subject statement talking about who was authenticating. It's got an authentication statement talking about the properties of the actual act of authenticating. And then it's got a bunch of attributes, which is that claim information that we've been talking about.
So JWT, so we've got a definition up here for JSON Web Tokens. But essentially, JWTs are an attempt to try and make this stuff a little bit more compact, try and make it such that a real person who's looking at this stuff can basically understand what's getting transmitted back and forth and delve into it a bit. They're JavaScript tokens, so obviously you get the advantage of really strong interoperability with JavaScript, but also with just about every other language out there. So really, really easy to use, and they start to get a lot simpler than SAML tokens did. So we've got an example of a JSON.
Whoa. Matt.
Yeah?
Matt, don't mess with this, Matt. That's not you said it was going to be JSON, man.
Right, okay.
Don't mess with this, Matt.
I'm only half messing with you. So this is base 64 encoded. So what we've got here is a base 64 encoded header, followed by a base 64 encoded payload, followed by a hash of those two things. And if we perform some magic and we base 64 decode this stuff, we get something that looks like this. So a JSON Web Token has a header in it. So that's going to start with type equals JWT. That's always going to be the case. That's going to be followed by a hashing algorithm. That can be RS256 or HS256. If it's RS256, it means it's certificate-based hashing. So you'll also get the thumbprint of that X509 certificate that's being used. Followed by that, in the actual body of the token itself, you've got a number of fields that are reserved. We haven't put the complete list up here by any means, but these fields are basically, if they're in the token, you can be assured of what they mean. They're very well defined. If you've got followed by that a number of public claims. So these public claims are also well defined, but they're defined in a separate registry. They're defined in the IANA registry for JWTs. if you see these, you know what they mean, but you don't necessarily, they're not necessarily locked down over time. They can be changed. And lastly, we've got a number of private claims. These are totally custom claims that you basically make up. So you can put whatever you want here. You just need to define their meaning on both your relying party side and on the identity provider side and make sure that they agree on what they mean. And you're not going to get great interoperability with other third-party services that you don't own by using them, but they can be pretty handy in certain situations.
There's a couple other things to note here. So you can see that there's a whole bunch of these really cryptic three-letter sort of claim names, which on first inspection is a little bit confusing, but the reason why they did that was very deliberate. The definition on the last slide talked about the fact that JWTs are meant to be compact. This is very deliberate to make them smaller because they're deliberately designed to be passed around in HTTP headers, so you kind of want them to not be too big, right? And that's actually also the reason why they're base 64 encoded, so there isn't any weird characters in there that mess with HTTP. Cool. So now that we've talked about token formats, we're going to talk about authentication protocols. Arguably, these are even more important to have standards for from a security point of view because the protocols are determines like what information gets passed around, who authenticates where. These are the ones where it's even more likely to have those little security holes. So for instance, for a period of time there, people were using OAuth 2 and actually had something called an open redirect attack in there.
So we've got a bit of a timeline of the different authentication protocols. It's really not important to remember what all of these are exactly. The important thing to note is that we started in around like early 2000s, and these protocols, SAML, WS Federation, came around in an effort for organizations trying to figure out, okay, we've got an application. We want that application to talk to an application owned by some other organization, but we don't just want to give them all our passwords. We need to do something smarter than that. So that was Federation. That was an attempt to solve that problem. They were also trying to figure out, really early days, how do we do single sign-on effectively? How do we try and make sure our users don't have to log into the 10 apps that we own as a part of our org? So that's what they were trying to do there. In the mid-2000s, we had protocols like OpenID come along, and OpenID was essentially an attempt by the social networks to try and figure out, okay, well, we've got a huge number of user identities. How do we start leveraging our brand a bit better and getting developers to start using those identities and spread them out a bit wider without compromising the security of our users? So they were trying to make it a lot simpler for developers to integrate this stuff in the hopes that that would start pushing that out. And they were obviously pretty successful as per what we see today. So that was all followed by, I guess, more modern protocols like OpenID Connect, which we'll talk about a bit more in a bit. But basically, OpenID Connect was an attempt to start simplifying this even further and really learn a lot of lessons from the past, especially around filling in some of the gaps that previous protocols didn't really standardize very well.
So pretty much every protocol on the last slide follows this basic flow. What will happen is the relying party will generate a redirect URL. They'll send the user on that URL and it will take them to the identity provider, at which point they're going to authenticate, and then the identity provider will come up with a response and a redirect URL back to the relying party, at which point it can process that response. Pretty much every protocol follows this basic flow. So what we're going to look at is just a couple of the protocols we saw in the last slide to give an example in particular of this first redirect URL. This is what WS Federation looks like. It's actually not too complex. It's got an instruction to the server, in this case sign in 1.0. It's got this WT realm parameter. I don't know why it's called that, but that basically identifies the relying party, and as part of the registration the relying party has with the WS Federation server, then the server will know where to redirect them back to. We've also got some context information, which is just transparent information that's passed back on that redirect back to the relying party. WS Federation uses SAML tokens as its token format. Now, confusingly, SAML is not only a token format, but also an authentication protocol. And much like the token format, look at that URL. That's just nasty, right? The reason why it's so crazy is that the request itself is a base 64 encoded SAML token. And then the whole request gets signed. It's a bit weird, but it means that there's bidirectional trust between the relying party and the identity provider. So it's incredibly robust. And like I said earlier, it's got a lot of support. If you are trying to integrate some sort of off-the-shelf or software as a service provider with your corporate identity, 9 times out of 10, you're probably going to be using SAML to do it. So it's a very powerful and well-supported standard. And then that leads us to a bit more of a modern protocol in OAuth 2. This is much nicer and cleaner. It's got an instruction, again, to the server, in this case, response type. We've got a client ID, which identifies the relying party. And in this case, we've actually also got a redirect URI where the user should be sent to after they authenticate. That's actually the source of that open redirect bug that I mentioned. If the server doesn't verify that that redirect URI is like okay in a whitelist, then you're kind of in a world of hurt.
Cool. So that leads us to OpenID Connect. So one of the really interesting things about OAuth 2 is it was actually just an authorization protocol. It was never an authentication protocol, but that doesn't mean that people didn't use it as an authentication protocol. They all just implemented it in slightly different ways. So Facebook, Google, Microsoft all had slightly different ways of doing this originally. So what OpenID Connect attempts to do is fill in the gaps. It actually standardizes authentication as well. It uses JWTs as the token type. It supports multiple different relying party types. So you can use like web apps, you can use desktop apps, server to server.
You can also use JavaScript running on a web browser, which is pretty cool.
You can. So there's a whole heap of different client types there. Depending on your implementation of OpenID Connect, there's a whole heap of other different things that it can provide. You can get token encryption. You can dynamically register your clients, so you don't actually have to configure them all in the app. They can register themselves if that's what you want. You can do dynamic discovery of all of the information about the OpenID Connect server by your client relying party application just dynamically, which we'll talk about a bit more in a bit. Dynamic session management. There's all sorts of really, really cool and useful features that simplify the whole experience for developers as part of this.
Cool. So now that we've covered the kind of basics behind token formats and authentication protocols, as we said, we wanted to do a deep dive specifically into OpenID Connect because it's becoming increasingly prevalent and important. And in our mind is probably the most important protocol to have some of an understanding of these days. So what we're going to do is break this up into a few parts because, I mean, we are talking, it is a very simple specification, but it's still a spec, right? So we're going to try to break it in easy for you. Because, I mean, frankly, when we learnt this stuff, like, it melted our brain. So firstly, we're going to talk about some fundamentals. These are the things that you really need to understand in order to kind of get what's going on in the rest of the protocol. Starting with relying parties. Now, as Matt mentioned before, one of the things about OpenID Connect that just confuses me is that it's literally an extension of OAuth 2, but it uses a different word for the relying party in the spec. It's just really weird. But one of the important things to think about with relying parties is registration. And this is important from two perspectives. The relying party itself needs to have some information about the identity provider that it's talking to. So it needs to know, for instance, the public key of the certificate that's being used to sign the JWT so it can do token validation. It needs to know a bunch of URLs so it knows how and where to talk to that identity provider. And then on the other side of things, the identity provider itself also needs to know about the relying party so that when it gets a request from that relying party, it knows that it can trust it. It's not some random app trying to hack in. In terms of the responsibility of a relying party in OpenID Connect, it's basically very simple. It comes down to that basic flow that we looked at before. The relying party needs to be able to construct a request, send the user on its way, and then deal with a response that comes back from the OpenID Connect server. In terms of dealing with the response, it needs to be able to verify the signature of any tokens in that response and look at the timestamp and the lifetime of those tokens to make sure that they're still valid and they haven't expired. They're identified by a client ID. Again, confusing, right? It's called a client ID, but it's a relying party. It's just crazy. Anyway, there's two types of relying parties. There's confidential relying parties and public relying parties. Confidential relying parties can keep a secret. So typically, it's something running on a server, whereas public relying parties can't. So typically, that's going to be either JavaScript running in a web browser or it's going to be a mobile application. But it supports both.
Cool. So one of the really, really cool things that OpenID Connect mandates is that you put up a metadata endpoint about your OpenID Connect server. So you put that up at .well-known/OpenID-configuration. That contains all of the information that your relying parties could possibly need to know in order to authenticate to your server. So that's things like all of the different API endpoints that you can hit for different information, the public key of your signing certificate, the different like token types and claim types and scopes that you support, etc. So this lets us do some really cool things that we previously haven't really been able to do easily. We can, for example, we could change the signing certificate that we use for our server. And one of the things that the spec mandates is that you only cache that information from this metadata endpoint for a certain amount of time, which means that we can change the certificate and we can guarantee that all of our clients can go update against that new signing certificate within a certain amount of time. Previously, that's something that's been quite difficult. You don't necessarily own all the different relying parties subscribing to you. So it's kind of cool, and it gives us a lot of power and flexibility.
One of the things I think is probably the most exciting bit about OpenID Connect for me can be summarized by this bit of code. All you need to do to use OpenID Connect at the bare minimum is something like this. You need one URL to the identities provider server. That's it. You pull in a library, you pass it the URL, it goes to that endpoint, it figures everything out, and you're good to go. That is just crazy convenient.
And this is obviously C# and Authn, but there's examples for basically every programming language out there, and they all look something like this at their simplest, just one URL.
Cool. So the next thing to talk about are scopes. Now, for those of you familiar with OAuth 2, it's exactly the same as in OAuth 2. So scopes allow you to tailor authorization. In order for me to try to explain what that means, I'll use an example. Say that you've got some sort of application XYZ over here that's trying to get you to log in to your Twitter account via that application. And then it asks for permission to read your tweets and also read your direct messages. Now, there's two types of scopes. There's required and optional. So the application over here can say, hey, you know what? For me to be able to function, my core functionality is that I can read your tweets. If you don't grant me that, just don't bother. But direct messages, there's this kind of sidebar, kind of cool, nice to have functionality. If you don't give me that, I will just adapt and hide that bit of the app. What this would look like in the UI is that it'll be like, hi, log in with your Twitter account to application XYZ. By doing this, you will be granting application XYZ the ability to read your tweets and checkbox, read your direct messages. And you can basically tick or untick that checkbox depending on whether or not you want to grant that permission. That act of ticking or unticking is called consent. That's basically how it works. The one thing that's kind of different in OpenID Connect is OpenID Connect actually defines a set of standard scopes. And then obviously you can also use whatever custom ones that you want as well. The standard scopes of this list here. The one at the top, OpenID, is required. If you're using OpenID Connect to authenticate a user, you have to request the OpenID scope. It's just part of the spec. The 4 scopes underneath that will grant you a subset of information about that user, and we'll look at what the subsets are in a bit. The last one's kind of interesting, offline access. If you request the offline access scope and it's granted, then you will be able to generate something called refresh tokens. And we'll explain what they are in a second.
So these are the 4 main tokens that you get out of OpenID Connect. You get an ID token. So this is just the user's identity, fairly self-explanatory. This is the JWT we were talking about before. We've got an access token. So an access token is just a representation of the fact that you've got permission to access something on behalf of a user. Also a JWT. Now, you can also have something called a refresh token. So refresh tokens, basically just the ability to get another access token when yours expires, and you might want to do that in certain types of applications. And the last type of token is a code, and this is just a short-lived code that you can exchange for a token in certain types of scenarios, which we'll cover a little bit later.
In terms of the scenarios where you might want to use refresh tokens, typically boils down to 2 scenarios. One would be where, say you're in like a JavaScript running on a web browser. It's a public relying party. So the tokens are like visible there. Now, from a security perspective, that means that there's a higher likelihood those tokens might be compromised, which means you probably want to shorten the lifetime of them. But what you can then do is have the access tokens be shorter lifetime and then have a refresh token with a longer lifetime that you can use to get new access tokens whenever you need them.
Cool. So this is what an OpenID Connect JWT looks like. One of the first things to point out here is that unlike in regular JWTs, there are actually required fields here that you do have to specify. So we've got the required ones up here. those required ones are basically just well-defined fields which always will have to be in the token. If you see them, you know exactly what they mean. You've got some optional fields here as well, which are just next on here. Those optional fields, again, they're well-defined. If you see them in your token, you can be assured of what they mean, but you don't have to specify these. And then that's all followed by a number of custom claims as well. And these custom ones are basically, again, you can make these up, you can do whatever you want with these, but you're just then limited in your interoperability, and you just have to specify exactly what they mean yourself.
Cool. So now that we've covered the fundamentals, the next thing to talk about is endpoints. There's a number of different endpoints that you can communicate with OpenID Connect. These three here are the required endpoints. They will be in every implementation of OpenID Connect server. There are also a bunch of other optional ones that we're not going to cover. The first endpoint to talk about is the Authorization Endpoint. This is the endpoint that you send users to log in. This endpoint will give the users some sort of UI for them to provide their credentials. Now, the endpoint will either return a code or an ID token, access token, and or refresh token, depending on which flow you use, and we'll cover that in a little bit. The initial redirect that the relying party sends the user on to the identity provider will look something like this. You'll have whatever the URL is for the authorized endpoint, and then there's 4 required parameters. There's response type, client ID, redirect URI, and scope. The response type we'll cover when we look at flows. The client ID identifies that relying party. The redirect URI is where the user should be sent to afterwards, and the server will check that against a whitelist. And the scope, as I said, has to at least have OpenID. It's space delimited, and then you can have any other scopes that the relying party wants to try to request. Optionally, you can also have a nonce to prevent replay attacks and a state that gets transparently passed back on the other end. Once the user is authenticated, the redirect back to the relying party might look something like this. You can see that redirect URI we had there will appear there. And then in this case, because we were asking for a code, we'll have a code passed to us. And then in this case, because we had some state, that'll be passed back transparently. That's basically it.
So we mentioned MFA before. If you're using OpenID Connect, this is a really, really cool place to do it, because you can do essentially anything you want at this authorization endpoint between the user getting redirected to your endpoint and then that getting redirected back to the relying party. So if you want to use this time, you can also trigger an MFA challenge at this point before that redirect happens. And that makes it really, really simple to integrate this stuff.
So the next endpoint to talk about is the token endpoint. This is an OAuth 2 compatible endpoint. Unlike the authorization endpoint, where real users hit and it has a UI, this is just for server-to-server communications. So it's basically just an API endpoint. What this will do is perform authentication of a relying party. The relying party, when it hits this endpoint, always has to authenticate itself. And then it will return some tokens. Now, there's a few different exchanges that can happen at this endpoint. But the 3 main ones are, it will either exchange a code for an ID token, access token, and or refresh token, or you can exchange a refresh token for an access token and a new refresh token to use next time. Or you can exchange some sort of set of credentials for an ID token and or an access token. And this will make a bit more sense when we look at the flows. Here's an example of what the HTTP request might look like. In this case, we've taken the refresh token example. So you'll do a post, HTTP post. You will perform some sort of authorization to identify yourself as a relying party. In this case, we've got basic authentication. So it'll probably be the client ID along with some sort of shared secret. But there's other mechanisms that can be used as well, like client certificates. The grant type is a required field that always has to get passed through. In this case, it's refresh token. And for the refresh token grant type, you have to pass the refresh token. And you can also optionally pass in a scope if you want to vary the authorization for this particular access token that you're generating. The response will look something like this. It's just JSON. You'll get, in this case, an access token and a refresh token. It's pretty simple.
So we've got an even simpler endpoint up here, which is the user info endpoint. So there's a lot of scenarios when you're building applications where you obviously need to know exactly who's logged in and what permissions you have. So this user info endpoint will return the claims that your particular relying party is authorized to see. So you'll get a subset basically of claims based on the subset of scopes that are requested. And we've got those standard claims up here if you want to have a look at that later.
So those standard scopes we looked at before, depending on which ones of those that you have, will give a subset of the standard claims that are here, and that's defined in the spec. Okay, so the last thing to talk about with OpenID Connect are the different flows.
So when you're choosing a flow, there's a few different things you need to make decisions on. You need to figure out if you want an interactive or a non-interactive flow. So that's basically, is the user involved or is it some kind of server-to-server communication? You need to figure out if you need a confidential versus a public relying party. A confidential relying party being, as we said, someone who can be, or something that can be trusted with a secret, so some kind of server typically. You need to figure out what credentials are being used and who should see them exactly. And you need to figure out what types of tokens do you need. Do you need a refresh token, for example, in this type of scenario because you don't want a very long-lived access token being held by a client?
Okay, let's start by looking at the interactive flows. These are the flows that involve an end user logging in at that authorization endpoint we talked about. Now, there's two different things that determine which flow you would probably use. And there's actually three flows. So we've got the authorization code flow, the implicit flow, and the hybrid flow. Now, it's worth pointing out, not all of these flows are going to be available in every implementation of an OpenID Connect server that you have. The authorization code flow does not reveal any tokens to the user agent that the end user is using, so say a web browser or something like that. The tokens are only existing in the confidential relying party, so they're kept secret. That's an important thing to think about. It is possible to use refresh tokens with that flow. Whereas conversely, in the implicit flow, you can't use refresh tokens, and the user agent that the user is using will see the tokens. And we'll show you a diagram of that in a second. The hybrid flow is basically the combination of the two. In the hybrid flow, the user agent can see the tokens, but you can also use refresh tokens. Now, if you cast your mind back to when we showed the authorization endpoint, there was one parameter that we had to pass in that initial redirect called, response type. The response type value determines which flow that you're using. So if the value is code, you're using the authorization code flow. If the value is ID token or ID token and token, you're using the implicit flow. And if it's a combination, then you're using the hybrid flow.
So we thought we'd show you visually what the authorization code flow looks like. Basically, in this scenario, the confidential relying party will redirect the user through to the authorization endpoint on the identity provider. The identity provider will then redirect the user back with an authorization code. And the confidential relying party will then check that code at the token endpoint with the identity provider in response for the actual tokens that are being used. So this flow is really, really useful in a number of different scenarios. Oh, there we go. Let's do it manually. So we've got here an example of what the HTTP request looks like.
So it's pretty much exactly the same as what we showed for the refresh token example. The relying party needs to authorize itself in whatever way. The grant type in this case is authorization_code, and for that one, we pass through the code parameter. And in return, we get the access token, the ID token, and if we requested it using that offline access scope, the refresh token.
Cool. So we're going to show you now what the implicit flow looks like. It's also called two-legged OAuth. In this particular flow, this is exactly the same as what we just had, except that the relying party doesn't necessarily do the same thing. The authorization endpoint will, in this case, return exactly the same tokens to the user as in the previous example you would have needed the relying party to go get. So the user themselves will own the tokens that are involved. So you can see here that user still provides proof of identity. They get back the access and the ID tokens directly, and then they just provide that straight to the relying party. In this case, everyone knows about the tokens. There's cases where you might not have a choice. You actually might need to use this flow. For example, in JavaScript applications, it's really common. We've got here an example of what the HTTP request looks like. The important thing to note here is that you can see the hash in the URL. That basically means that the server doesn't ever have to see this particular ID token. It's all held purely on the client. Cool. We've got the hybrid flow up here. This is the third flow that we want to talk about. The hybrid flow is exactly the same as the implicit flow, but you also have refresh tokens. And you might need this in certain scenarios, or again, you don't want a particularly long-lived access token to be held. In this case, you pass an authorization code as well, and you can exchange that at the relying party on the identity server in exchange for a refresh token, and then use that from there.
Cool. So now that we've looked at the interactive flows that involve real users, we can look at the non-interactive flows. Now, these only involve server-to-server communications. Kind of, as you'll see in a second. Now, the first one that we're going to look at is something called client credentials flow. So, can you just hit the
Yeah.
So in this flow, the relying party will pass its credentials to the token endpoint with a grant type of client credentials, and in return it will get an ID token, access token, and/or refresh token that identifies that relying party. This is useful for server-to-server communications where you want services calling other services in the background asynchronously and that kind of thing. The cool thing about this is this means you can use your identity provider not only to identify your users, but also to identify all of your servers. So you kind of get this added benefit. It's quite powerful.
Yeah.
So the next one is called resource owner credentials flow. Say that 10 times fast. Now, in this flow, the relying party actually takes the credentials from the user. Now, we've obviously been talking about how that's a really bad idea throughout this presentation, but there are some circumstances in which it's still a reasonable thing to do. So for instance, say you've got Facebook. They've created their own mobile app. If you go and look at it, you'll see that the username and password fields are part of a native experience. It's not popping up a web browser. So they're not using one of the other flows. They're doing something like this. The reason for that is because they want to control the experience of the app and make it nice and native. And they can do that because they're the ones that built the app. So they know how the app handles the password. It doesn't siphon it off somewhere or do something dodgy. And they obviously also control the identity provider on the other side. However, if you think about a third-party company creating a mobile app that you get people to log in on behalf of their Facebook user identity, there's no way Facebook is going to let you create that kind of experience. So in that case, that's where you have to pop up that web browser and use the other flows where you're only ever entering the credentials into the Facebook website. This is an example of what the client credentials flow looks like from a HTTP point of view. Very similar to the other two examples we showed, and really basic. You just pass grant type of client underscore credentials. And then for the resource owner credentials flow, very similar, grant type of password, and then you pass in the username and the password. So, as we said before, trying to get our heads around the OpenID Connect spec, you know, it's brain melting. It's a very simple spec, but it's still a spec. There's still a lot of little aspects to it. But you don't really need to know it in real depth. As we said, you can just pull in a library. So I guess the takeaways that we'd want people to get from this talk would be, you know, an understanding of claims-based authentication, knowledge about, say, JWT tokens, understanding that OpenID Connect is a thing and that you should use it for authentication rather than OAuth 2. Understanding that OpenID Connect has a bunch of different flows and there's a few just different decision points to choose which one. That's pretty much all you need to know, because from there you can probably go and have a glimpse through parts of the spec. It's actually reasonably well written. It's quite simple. And sort of from there figure out, okay, in this scenario, this is probably what I want to do. So what we're going to try to do is to just a small demo of an OpenID Connect server, just to illustrate a couple of the concepts that we just talked about.
Yeah, let's go with that.
Cool. So So what we've got here is on this computer, we've created an identity server at localhost 44399/identity. And if you remember from the metadata slide that Matt talked about, why did that move? Oh, that's why. There's that move up, .well-known/OpenID-configuration. Now, some of the things that we see in here, things like the issuer, we've got the authorization endpoint, the token endpoint, the user info endpoint that we talked about. We've got a whole bunch of other things like the supported scopes, and you've got things like the supported response types. So these are all of those flows we talked about. Like I said, not all OpenID Connect servers will support all of the flows. This one does. If you're curious, this is using IdentityServer 3 on .NET. A really important URI in here is this JWTS URI there. So if we click through on that, JWTS stands for JSON Web Key. It's basically a format that allows you to describe, I guess, a public certificate in JSON format. So all of these values here represent the public certificate of the signing certificate that this identity server uses to sign JWTs. So the relying party that pulls in an OpenID Connect library can go and hit this endpoint, hit this particular URL from the endpoint, grab this information, and it's got everything it needs to be able to verify whether a token is intact. As I said, really powerful stuff. So what we've got here is a JavaScript client that's going to be using implicit auth against that OpenID Connect server that we had. So we're just going to go to the network tab here, and we're going to click login. Cool. Oops. So as we can see here when it loads, control 1. Yeah. It's taking ages to refresh for some reason. As we can see here, we're actually on that identity server now. This is based off hitting the authorization endpoint we talked about, and we've got a UI here to put a username and password in. Now, before we do that, if we just go to the F12.
Yep.
Where's F12
Just
gone?
hit it again.
Okay, cool. Here we go. So, here's an example of... Move the thing right. Here's an example of hitting that authorization endpoint. Maybe just zoom out because that's crazy. So it's probably a bit hard to see now, but we hit that authorized endpoint. We pass through a state, a nonce. We pass through a client ID, in this case JavaScript _implicit. We pass to redirect URI, which is HTTP localhost port 21500/index.html. We also passed a response type of ID token, so we're just asking for an ID token, and we're using the implicit flow. And we also pass through that required scope of OpenID. So this is all the stuff that we were talking about. And then this particular identity server has given us this login page. If we log in, got it wrong, dude. Do you want me to type it?
Yeah, go for it.
All right, hold that. Be awkward if I got it wrong too.
There you go.
Is it working?
Yeah.
Okay, it's a bit slow. So now, we can see we got taken back to that index.html on localhost 21500, and we've got the hash there, so the server would never have seen this. We've got the ID _ token value there, and then a whole bunch of other stuff. The JavaScript's basically just shown us the parameters that were passed here. So you can see we also got the scope and the state and stuff like that. Now, that ID token, if we grab that value, do you want me to do it, or? It's quite long.
Cool.
Nice. And we go to this brilliant site called JWT.io. If you want to take any takeaways from this talk, if you're working with JWTs, remember that site because it's awesome. You can paste in on the left-hand side, and on the right here, it's decoded it for us. So on the header there, you can see that type we talked about. We've got the X509 thumbprint, and then here we've got all of our claims. So we've got that issuer, localhost 44399. We've got the audience, which is our client ID. We've got the expiry time in Unix format, the nonce we had, the time it was issued, and the subject. So that's the username that I typed in, username. One other thing I'd point out about JWTs, just scroll up. you pretty much know you're dealing with a JWT if you've got EY followed by a bunch of stuff, followed by a dot, followed by EY, followed by a bunch of stuff, followed by a dot, followed by a bunch of stuff. So you pretty much look for EY and then a whole heap of stuff, and you typically got a JWT. The reason why is because the base64 encoded version of squiggly bracket followed by a quote is EY. We'll flip back to the
Cool. So we've got here a few examples of links that you might want to go have a look at. These two links at the top are a pretty complete list, pretty comprehensive list of all the different implementations of OpenID Connect that you can go and have a look at. You've got a few different software as a service ones, a few different self-hosted ones, which are basically off-the-shelf ones that you'll just set up and go with. And then we've got a few examples at the bottom, IdentityServer 3 being one of them, of servers that you can set up and really customize yourself, which are really, really useful to have a look at.
It's useful when you want to do like a lot of custom scopes and claims and authentication kind of calls and stuff like that.
Cool. And that's it.
Thank you.
Thank you.
If you want to get the slides, if you go to bit.ly/modernauth, that'll pop you off to the GitHub where we've got the slides. Cool. Any questions? Hello.
Hey, after kind of suffering through hell to integrate. Okay, so after suffering through hell to do Auth 2 with GitHub, Dropbox, Google, Facebook, and a bunch, and that's kind of done. So what would be the key benefit of, I don't know, redeveloping that using OpenID Connect? Is there a benefit of going through the exercise again? And
Yeah. So the question was, you've got an existing site. It's done all the different libraries for Dropbox, Google, and Facebook, or whatever it is, all using OAuth 2 rather than OpenID Connect. Should you move across? I guess it depends on whether you trust that all of those different libraries that you've pulled in don't have any security holes, right? Because obviously there's quite a few, so that any single one of those could have a hole that the others might not have, right? To be fair, those companies are pretty big. They're probably pretty robust. They've been used a lot. If it's working, you probably don't need to touch it, right? But like going forward, you could potentially use something like this because it's an easier standard. Next time, you don't have to pull in 5 libraries. You just pull in 1 and you're good to go, right?
Can you go back to that slide or which one, where are they in your presentation?
The JWT one or the SAML one?
The JWT one.
Yep.
Before the MFAs.
Oh, yeah, cool.
Yeah. Laptop's a bit slow, so it might take a sec.
So the slides where we're showing the flows, by the way, like the clicker wasn't working. So to get the full effect, it's probably better to download the deck and make sure you look through because it's a lot easier to understand when you see it bit by bit.
So my question would be like how that in the slides they would easy for me to ask, I guess. So we have that second option, not the reference token, the other token, which is on claim token.
Yep.
How would the relying party know that this token is a good token? I mean, are you
Sure.
able to
Yeah.
check the
Good
certificate
question.
on every request to see that the certificate is valid, that has been used?
Yep.
See, there's no arrow going back from there to
Cool. Really good question. So the question was, in the self-contained token, helps if I turn it on, in the self-contained token example here, how can the relying party know that this token is valid if it's not communicating directly to the identity provider? The reason being that this step here is what does it, the token validation. So the token formats we looked at, both SAML and JWT, both have a component inside of them with a cryptographic signature. That cryptographic signature is signed by either a secret key that you've exchanged previously with the identity provider or by a public-private key pair where you know what the public key is. So that JWTS URL that we looked at for OpenID Connect, that's the public key of the certificate it's using that it has a private key for that it signs the certificates. So what you can do is you do the cryptographic hashing algorithm on the contents, and then you can tell if the signature is different. So the signature is different, the token's been tampered with, and thus it's not safe to use.
Tampering is fine, I can understand that, but how do I know that the key that was used to sign the whole thing is a key from the...
Right. Yeah. So you would know if the key used to sign the token is the same key based on that registration step I talked about, right? That might involve exchanging a pre-shared secret key, or it might involve, in the case of OpenID Connect, going to that well-known discovery endpoint, pulling out the public key, and then using that key.
So there are some more errors really in this diagram.
Sure.
Either pre or...
That's a fair point, but that would happen like once only or in the background asynchronously. If in the actual authentication flow, this is it. It doesn't need to talk to the identity provider because it's previously exchanged information, so it knows how to verify the token.
The other question is that in this flow, is there a case for how would I use my own digital signature? Like for example, there may be a case that I am the, I mean, you don't, I mean, this guy Reliable doesn't know how this token has been obtained. Like if I
Yeah.
have had this system, I could have obtained a token.
Absolutely.
I might
Yeah.
have a token already from somewhere else, even if it's short validation or not. But in some case, like if I have my own personal digital signature, can that be used in this kind of flow? In some case, you might need for a contract or something that I am really the person who is that person, you know?
Mm-hmm. So the question was, the token, you know, you don't know how it's been obtained, you just get this token. This is actually the concept called bearer tokens. So bearer tokens means the person holding it, just by the nature of the fact that they're holding it, you have to trust it, if that makes sense. Now, obviously there's circumstances where tokens might get compromised, and that's where you do things like lower the lifetimes of access tokens and stuff like that, so that if they do get compromised, they can only be used for a certain amount of time, and then they're not useful anymore, if that makes sense.
Yeah, but that's not foolproof. Like you're talking about time.
So, okay, so
If I have my own like personal digital certificate, sometimes you have like...
sure, yeah. So depending on what protocols you use, there may be some protocols that allow you to use certificates in a slightly different way. Like potentially you present a certificate at this point and that somehow gets encoded in the token. In terms of OpenID Connect, what you're relying on is that it's always over HTTPS, and so you trust that the token it's very unlikely that the tokens have been compromised, if that makes sense. So the combination of HTTPS combined with token validation means that you generally can just trust the tokens. Any other questions?
Do the major identity providers like Microsoft, Google, Facebook, and that, do they all support OpenID Connect already?
Yep, so the question was, do the major identity providers support this? Pretty much, yeah. I don't know off the top of my head if Google does, but I'd be damn surprised if they don't. Microsoft definitely do. So pretty much, yeah. So that's probably all we've got time for. Feel free to hit us up later and we can answer any questions. Thanks, guys.